Today is a special day because we have a guest here, Schalk. Thank you for coming to our meetup. I think this is our first meetup here in English. Thank you all for coming. It's Friday afternoon, so I'm going to be very fast here. So is there anyone which is the first time here in Madrid-GUG? You already came, so you know everything. Perfect. So, oops, doesn't work. Okay, so just a few things. I'm not sure if you know this. I know that some folks here know. This Open Collective thing is a portal or a thing to basically raise money for open source project, so you can contribute to your favorite open source project if you want. So this is the URL for Apache Groovy, and as you can see, there are a lot of bakers there. So you can do one-time donation, or you can put some money every month. And this will help the project to basically develop new features, because as you know, there is only one committer that is being paid for developing in Groovy, it's Schalk. But the rest of the committers do that on their own time. And I saw this last night. Marco Vermeulen, the creator of SDK Manager, launched another Open Collective thing. So if you use SDK Manager, and you should, to manage everything in the MEA SDK, Java version, Gradle, Rails, Micronaut, whatever thing, you should put some money here to help Marco with this, because he's been doing this for something like 4 years now, or 5 maybe, a lot of them. So it's nice to be able to contribute to tools like this that save us a lot of time. And more things. CodeMotion, Madrid, it will be in September 24th and 25th. The call for paper is already closed. It was closed, I think, 2 days ago, 14th. So we are going to start the community votes. I will probably send a link to our mailing list during this weekend, so you can vote for the talks. And if you are interested in coming to the conference, it will be in the same venue as last year, in Kinepolis. 24 and 25th is, I think, Tuesday and Wednesday, pretty strange days. And if you're interested, take a look at our website, our mailing list, because I sent the other day a discount code, a 20% discount code for our members. And if you want to learn the discount code, let me know and I will share with you. And ComicConf, this year it's in November, as it has been all the time. So you know that, or maybe you know that now they are, Commit and CodeMotion, they are something like friends again. And CodeMotion it's in September, they are in November, not like the last year, which they were just 1 week apart. The call for paper is open until May something, so you can submit your talks, and we will have the votes, and again, probably during late May or something like that. And as always, our sponsors, Virtual Software, Jose Miguel records our talks, and Virtual Software pays for the meetup. JetBrains, I will raffle JetBrains license with a new not random.org tool that Jorge did, and we will show here for the first time. OCI, which pays for the drinks, and Grid, we pay for this screen recorder, I think. And I think that's all. So it's on you. Thank you.
I'll set this up quickly. No, look like pictures. Your screen.
Me gustan las fotos de esto que sale en Twitter.
Oops. I actually recognize some other faces from conference, so that's good. I would actually have to say thank you for even organizing this, because I said, I'm coming to Madrid only for one night, and can you do something that's on a Friday? I said, I'll see what I can do. Well, he's arranged it, and thank you for coming. So my name is Schalk Cronjé. That's my Twitter handle, my email address if you want to get hold of me. So I always have to apologize, I can't speak Spanish, and he always makes fun of me because I can speak some Catalan but no Spanish. I live in Andorra, and I work from there. We run a small consultancy. Well, there's reasons why we live there. We run a small consultancy from there, and most of the work we do are for other clients. I tend to find work, then I find people out of the network, and I effectively find work for them when we do a project. And in that way I can actually do projects for clients who are very, very good people, and when they're done they can go find other work again if they want, and this is the way we generally work. And so far it's actually worked quite well for us. So I always want to look at finding people with good skills, because I never know when I can find a project, and I have some freelancers available who can actually work on a project. Anyway, so what I wanted to talk about really is two things. When we discussed this, the one thing was the concept of DocuOps, and I actually want to talk about Asciidoctor and how the two things fit together. So you might have heard the term DocuOps or not, and it's really about automating the documentation pipeline. And the old days, we always had the problems of people writing documentation. Well, the people write documentation on that side, the people write the code on that side, so they never meet up. But if you look at it, in the modern world, we can actually treat documentation as an engineering problem. And we can apply a lot of the things that we do for normal software development to documentation as well. And I'm not going to run through all of the kind of things, just a couple of topics. And the first thing is what we really want to do is go through the effect, like we do with software, where we can actually do a commit, and from a commit we can have a full build verification and actually get to deployment. And you can do this all, if your pipeline works like that, you can actually go from commit to deployment without in the interaction. We want to do the same thing with documentation, and to a great extent we can today. The big thing we also want to do is we want to reduce the manual proofreading to as minimal as possible. Now, in software, we generally have the concept of code reviews. Obviously, you can just commit and go, but we generally like to still look at code because there's things that humans can spot that other tools cannot. And when writing documentation, you have exactly the same kind of problem. And it's just slightly different because you will actually look at some very, very good tools and the documentation is really bad. There's really two reasons for that, because people write the code and they forget about the documentation. The other thing is people are so focused on writing the code when they write the documentation, they look at it the wrong way. So you generally need someone else who can review it and copy edit, and because they just will look at it differently, the code after the docs will actually can very, very easily be improved in that kind of way. And I mean, a lot of the plugins I've written has pretty decent documentation, but I can tell you now a lot of them isn't as good as it should be, simply because some of the things we do on our own, and it's not somebody else looking at it. Just by somebody reading and trying to use the plugin and says, well, I can't understand this, will really give massive feedback, because then you realize they're looking at a different point of view, because I was looking at it from solving a specific problem, so I wrote sort of the documentation around that, and then they look at it from a different point of view, which doesn't have the context that I might have had. So that's why we still need it, but we just want to reduce that kind of manual proofreading to as minimal as possible. And the other thing we want to do is to reduce the distance between development and documentation. You will all know if somebody tells you to write something like documentation in a Word document or something, it's never going to be in sync. So we want to bring this closer together. So one of the things is, typically if you do Java doc or Groovy doc, is a very, very good example, because the two things are very close. We write the code, there are documentation for the API. Obviously, you're not going to put a usage documentation there, so you still want to bring it inside as possible. So the great thing we want to do is, let's write a documentation in the same resource repository where we write our code. That's the first thing we can do to bring it closer. The second thing we want to do is, if you write documentation that contains code, we actually want the code that's in the docs to be up to sync. So in other words, they must actually run and be testable. So we want to bring all of that in. And then the other thing we want to do is we want to focus on the content we want to write and not the formatting. If you write something like Word, half of the time you fight with the formatting because the bullet points are full. Suddenly there's an indent which you can't figure out why it's there. So you want to remove all of that. And we really just want to focus on writing the content, and somebody can easily review that content as well. And then later worry about the formatting. And then we also want to basically do this concept of we want to write basically once and then try to publish to multiple formats. Now, this is generally, if you've ever written any code that's native and had to run on multiple platforms, you generally realize it's not quite true. There's always some adjustments you might have to make for some platforms. But once again, you just want to reduce it as much as possible. And then the other thing we really want is, let's focus on text-based markup because, firstly, you can put it on source control. You can easily compare it. You can use existing engineering tools to fix your documentation and look at it because it's very easy to see somebody's focused on, when they focus on content, they've written things, you can compare them. They've made these changes, and now I can just review those changes. And the one thing is, once you get into this kind of thing, you realize it's not just for technical documents. And in our company, we generate all of our legal documents in this way. It's actually all done in Asciidoc. We just fill in basically the new details for a contract, and it generates a contract from a build. So it can all be done. And I actually know much bigger than my company, big legal companies, a couple of them have done it the same way. So they've actually automated the whole documentation line for all of the legal documents. So that's basically what we want to focus on DocuOps. And that's really what you're talking about, that is the kind of thing. The other thing obviously talk's going to be, there's going to be a lot of Gradle in this talk. And the reason for it is that Gradle is not just a tool for building like Java, Groovy, Kotlin apps. It is really a very, very advanced tool for building automated pipelines. And you can do, and if you set up your Gradle builds correctly, you can run most of the things on a local development machine just as what you'd be able to do from CI, which a lot of other tools cannot do. And the other thing I'm obviously going to talk about Asciidoctor documentation, but if we look at today at the Asciidoctor Gradle plugins, it is probably the most advanced integration that you can find between build tooling and something that actually creates documentation. For instance, there's an Asciidoc plugin for Maven, but like that plugin, Maven is really a tool for doing one thing, it's building Java apps. Once you start trying to build more complex apps or more complex pipelines, it just falls apart. It's not designed for that. So that is one reason why there isn't very extensive functionality in the Maven plugin like there is in the Gradle plugins. And with the new releases of the Gradle plugins, you'll actually see what you can now do. But what I want to do now is just step through a couple of things because there's a lot of confusion in the community about what's what and what kind of tool there is, etc. So the first thing I want to say is that earlier this year, Asciidoctor J has been released. Now, Asciidoctor J is basically an implementation of a converter for the Asciidoc format, which runs on any JVM platform, but it's based upon JRuby. So it actually uses the Ruby engine underneath, it uses JRuby on top of it, and then you can actually use it like the normal Java. And what happened, most of the people still use Asciidoctor now, use 1.5, 1.6, the first moves towards breaking some of the APIs have happened, but not too many. And it's still effectively compatible with what was 1.5. The only thing that you have to do, if you have extensions that you wrote for like Asciidoctor J, you'll have to recompile it for the new version. But then a couple of weeks ago, Asciidoctor 2 was released, which is the Ruby implementation. Now, these versions no longer follow each other. They're roughly related, but they don't follow each other. They all use semantic version. And this was a very, very big change, or a step change for Asciidoctor 2 because there's a lot of API changes happened in that. It obviously now follows semantic version, but it's got things like, it's now got pluggable syntax support. So you can write your own syntax highlighter and plug it in there if you want. Or if you find a syntax highlighter that you like, there's no support for it, you can just write a glue layer now, which you couldn't do before. It's got a new converter API, which makes it a lot easier to write patterns. I wrote a converter a long time ago for converting Asciidoc to leanpub format, so I could write a book in Asciidoc and publish it on leanpub. The new API will make it a lot easier because a lot of things we have to really jump through hoops to get it done, especially if you didn't write it in Ruby. And the one I wrote was written in Groovy. Right. I'm not going to talk too much about this, but basically the plugable syntax highlighters now, the standard ones you found are all now extracted out of the core, and they are separate highlighters, and they are all follow this new syntax. And you get a couple of extra features you get with it. For instance, if you use highlight.js, you can now use the language attribute, so you could say, I want to use that, I want to have syntax highlighting for 4 or 5 languages of your own specification, whatever highlight.js supports, because by default it doesn't support all of the languages. And you want to have different languages, you have to download your own bundle and then plug that into your conversion. Now it supports that out of the box. And obviously I said it's got a new converter API. I don't want to spend too much time on that, I just will give you an idea what's going on, so I can skip over that. And also the formatting. Right. One of the nice things is you can actually run from the command line now. You can have a little cheat sheet if you run it with help, and it will actually give you a lot of the things you can do which you didn't have before, which is some things about the basic Asciidoc syntax. And if it finds unregistered backends, you can actually delegate to something else. So if somebody is specified a specific backend, so say like you specify DocBook, like there's no DocBook converter, there's only DocBook 5, you can actually have a delegation that goes from DocBook to DocBook 5. It will pick that up. Right. Now, we had another release, and it happened this week. And this time it's Asciidoctor J2 that got released, which now sits on top of Asciidoctor, sits on the Ruby version 2. And what the big thing that's actually happened there is that there's now 2 jars, the one's an API jar and one's an implementation engine. And the focus for the long term for this would be that there's a standard API for Java, but we can plug different engines in underneath. So it would be possible, for instance, if you write a new engine and you want to write it in Groovy, argument's sake, you can just drop it in there, or anything else. It's now incompatible with any previous version, so like, once again, if you've got extensions or converters, you have to recompile them to work with the new API. Oh, okay, let's skip that one. Right. I'm actually going to talk about the Gradle plugins, but basically what we had is, we had a whole number of releases. Who currently uses Asciidoctor? Uses Asciidoctor with Gradle. Pretty much the same people. Right. Okay, so we had 1.5 running for a long time. We also had then a 1.6 release, which is effectively still 1.5, but uses Asciidoctor J 1.6. We've placed all of those in maintenance mode, and we are only going to do critical features if required. They're also not supported on Gradle 5. If they run on Gradle 5, fine, but we're not doing any support on that anymore. So, in time for Bridge, we released the new Gradle plugins, and that was version 2. We released version 2.1 last week. This week, actually, we released it this week. Now, Jorge has very effectively been our beta tester. He's found a couple of things, and there's a couple of things he and Mario actually found that's in the 2.1 release. We're also lining up a 2.2 release, which will be here in a couple of weeks. And then we are working on a 3.0 release. Okay, but anyway, let's talk about 2.0, because there's very little change between 2.1 and 2.0, it's just effectively bug fixes. The first thing we did, and we learned from this in the 1.5 series, is that when 1.5 was written in the previous releases, it was still working the days when Gradle didn't run as a daemon. And it was like static data out there and things. And you would run a build, and the second time you run it with the new version of Gradle, it just wouldn't work, because like your extensions would have disappeared. So we fixed that problem. Everything now runs using either worker daemons or as an external Java process. By default, it will use Java exec and not the daemons, the workers, because unfortunately, Gradle workers are not as great as they are made out to be. And they still haven't fixed some of the bugs. There's still too much class path leakage and things that's happening there. And like if you run PDF back end, it just breaks because there's snake YAML on the path that gets introduced by Gradle, because it's got snake YAML somewhere, and it's got different versions, and things just fall down. So that's why my default is Java exec. But you can try other versions. You can use, there is a keyword, and you can say in process, and you can say, for instance, in process, and it will actually run it as a worker daemon, and you might actually get a performance improvement if you do it that way. But the only reason we use it on Java exec is because it's stable, it works with everything. Right, and now the first big change is we actually improved the global configuration. And I'm going to step off here to show you. So, previously we only liked an Asciidoctor J and it only had one line in it. Now you can do a lot of things because it's much more modularized. Generally you wouldn't specify the things, but there are cases where you would. For instance, by default, if there's a new version of Asciidoctor J release and you want to use it and the plugin hasn't supported yet, you can just change the version. You can set it there. If you write extensions inline and use the Groovy DSL for it, you can specify a version. And then for PDF EPUB, and if you want to use Asciidoctor diagram, you can specify a version. Then you have the normal things, options and attributes that you can set. But where this is getting different now is that's all global settings. You can override that on a per task basis. So if you find like a bug or you have an old backend or something that doesn't work globally, you can go in a specific task and override any of those, and only that task will ride with those. And it will then if anything you don't set, it will be reused from the global configuration. So you've got massive flexibility now. That's why, so basically you have the global project extension. You can set like, I want to set my table of contents level to 2 levels, but in my specific task, I want to add something else. So that specific task will also add a table of contents on the right. Whereas any other task, Asciidoctor task I might run will not have that. So you have all of the kind of flexibility and adjustment. Then one of the great big old problems was you can actually set the fail on warnings, which I didn't do in my presentation, by the way, so I missed it and I included it. But now you can actually do things. You can just say fatal warnings missing include. So if you have a bunch of files in your, say, you use the wrong file name to include, you can actually fail build on that, which is a massive improvement. And anything else. For instance, a typical thing that will warn you about an attribute you reference in your document but it was never specified. If you want that as a bug, as an error, you can do that. You just give it another region. So you can do all sorts of little things. Right. Now, the other thing we really improved is the way you can do extensions. I think you've written extensions, because Jorge has given me some nice examples as well. What we do is, I feel like with the Gradle plugins we write are the people that create the magician's wand. What we just give the wand away. There's other people that actually wave the wand that make the difference. And I can look at some of his examples and stuff. But anyway, so we've got extensions. You can do it in different ways. You can write it as a string, you can read it from a file, you can write it as a closure. And then you can even load from a sub-project in your same Gradle project or as an artifact. So you can pull someone else's extension and publish and include it. And the way we do it is actually the extensions are global by default, but once again you can add an extension per task. So if you run a normal HTML conversion a task and a PDF task as a separate one, you can have different extensions applied to both, and those set globally, which you couldn't do before. You had to write all sorts of workarounds to try and work out what's the backend before you run. So this is an example. We can just do an inline extension as a string. Sometimes strings are useful because you can do substitution into a string if you use it in a G string. Although obviously not always going to get the proper syntax by writing it down in a string, you can get the ease of failure. So you might want to use a different approach. For instance, you can use straight closure and then you effectively put Groovy syntax highlighting happens in there. Which gives you other advantages, which means you can pull in variables from somewhere else. Now, the one thing that you have to just keep in mind is something that has failed. These things are serialized because we run them out of process. So we actually have to serialize the closure, which was fun because if you have to implement it, you actually have to dehydrate the closure, send it off, and then rehydrate it on the other side and make sure the class path is still correct. And Then Gradle does something with closures as well. Then you find out, oh, it just doesn't work. And then internally we had to add another object to the class path that somewhere comes out of the internals of Gradle. But hey, it works. But anyway, this kind of stuff we did, so you can have the benefit. You can obviously just pull it from another file, which is also useful, so you can write a Groovy file with an extension in there. And the difference is, I want to go back, you'll notice all of these, basically I said Asciidoctor and I don't use the extensions keyword. And then give it a file. And if I use it as a sub-project, I could just say project, and it will actually pull, it will recognize it's a project. And it will do all of the manipulation inside to pull everything in this class path. The same thing that we do with normal dependencies in Gradle. And then finally, if you actually, what actually happens is, remember I originally said that you can set a Groovy DSL version. If you don't set any of those versions originally, it doesn't put any of those extra jars in the class path, which means your task only runs with what it needs, and you don't have accidental class path leakage. If you use the extensions keyword, it will automatically take the default version of Groovy DSL that's defined and put it on the class path, because it realized you are going to do an extension. So once again, you have to do less. And if you decide this version doesn't work because you're using some new feature in Groovy DSL, then you can override the version. Then the final thing is, if you actually want to pull in an artifact, you have to create some kind of configuration and then pull it like you would normally do. And the only other thing that you would do is you have to tell Asciidoctor that there's a configuration you want to use and what it means. And once again, it will go off and work out as an extension and take everything that's on that configuration and put it on the class path. Okay. Right, I know this is a lot of things that happen, so you have to go back and then read and then try. Okay. Now, the other thing that we found with the task configuration is this. I mean, the Gradle plugin has gone through a couple of changes in the DSL. Prior to 1.5, we had one original way which was very, very assignment based and was very basic. They were just basically the first plugins that were created out of the Hacker Garden. Now, we've learned that we made some changes, we made even more now. It's even more simple now. But it also gives you more flexibility. Right, so the first thing you can do is all kind of stuff. If you want to define, if you want to start a task and you apply the plugin, basically all you have to tell is where to find the sources and give it a directory and then what sources to include. Basically it uses that source directory as the top or the root of all sources and will resolve everything relative to that. And if you don't tell it sources, it will find all of the ADOCs and a couple of different patterns down that tree. So it will try and convert all of them. So typically, a lot of times you'll just do something like that, especially if you like to do a presentation. The presentation only really has one top level file, so you can do that. Obviously you can specify more files, etc. Those kind of things that you have to learn. Then you have to tell it where to place the output, and you can override it. Now any of the tasks that get automatically created by plugins will have some free defaults, but you can override. And typically it would be, say, in the build directory underneath the docs directory, and it might have the name of the task. Okay. And then we found another problem people struggle with is they have secondary sources. So I don't know if you know that in Asciidoc you can add special headers and footers automatically. So for that you have to specify a footer and a header file, which is called docinfo files. They never end up in the final output, they get used as part of processing. But you want Gradle to rerun your tasks if any of those files change. And the old days you have to go and remember this manually, you have to go input the files and get the paths to the files. To a great extent now you don't have to do that. We have a block called secondary sources, and you could do something like include docinfo start XML, for instance, if you use the docbook backend, or docinfo start HTML. By default, Gradle will do the basic ones for you. If it realizes you do an HTML backend, it will already have those secondary sources. But if you've got any other files that are part of your processing that doesn't end up in the final output but are required as inputs, then you can just specify them that way. And once again, it still uses source there as the basis, and it works exactly the same as source, except they are just used for checking that they have changed and whether the task should be run. And then we have the standard kind of thing of specifying resources. We can do a lot more with resources now as well. But the basic idea is, yes, there's files you want to copy from your source directory into your final output directory. So if you generate HTML output, that's something you want to do because you want all of the images in it. If you do PDFs, you don't want to do that. You want to know about the resources, so that it reruns if the resources changes. There's a way of actually configuring that so it doesn't copy it. But if you use the Asciidoctor PDF plugin, it even knows that. So it won't even copy it. So I'll get to that one now. But that's the kind of basic things you define. So we have three kind of concepts. We have sources, which are actually Asciidoc files. We have secondary sources, which is files which affect the output but doesn't get copied. And we have resources, which are files which just directly gets copied to the output directory. Then, as I said, you can actually control this manually if you want. You could just say copy all my resources always. Copy none of my resources. Or if I use some kind of backend, I only want to copy resources if the backend name matches. But once again, we've got so many defaults, good defaults in some of the tasks that you don't, most of the cases you don't even need to do this. This is typically where you start using different backends, which is a part of the core offer. And then what we found previous is, for instance, if you use the data or diagram, it used to create temporary files inside your source directory as it processes. So instead of polluting your source directory, you can actually tell Gradle to do all of the processing in an intermediate work directory. It will take all of your sources, copy there, all of your and everything else it needs, like the secondary sources, and it will run the processing in the in the intermediate work directory. It will adjust anything that Asciidoctor has to know about, like the base directory, etc. And you wouldn't even notice the difference. But it can take care of the problem if you have that kind of problem. So all you have to tell is to use an intermediate work directory. That's it. And then the same kind of thing, if you have certain things that gets generated in that intermediate directory and you want to copy them out, you can just say copy everything from intermediate directories using this pattern. And it's implicit. The moment you say that, it automatically starts using an intermediate work directory. In most cases, most people won't ever need this, but there are definitely cases where you will find this kind of problems and you want to solve them. So you don't have to do any difficult workarounds, it's all in there. And then we can now run conversions in parallel. So instead, previously it used to circle for every document in sequence. If you want and you have enough resources available, you just tell it to convert the documents in parallel, and it will fire up as many parallel resources as which there are CPUs available. Okay. And then you can add if you find anything else that you just want to get on the class path, you can just use configuration and tell it to put those additional items on the class path. You used to be able to do it anyway, but this is just not clear how to do this. There are no default configurations now. At previous times we used to have a configuration called Asciidoctor. We don't have that anymore. You have to create your own configuration and tell Asciidoctor about that. But that's not a big change. For most people, it would never affect them. Okay, and then if you're going to run things in parallel or convert, you can actually fine-tune how it forks to run these processes. Because if you run big conversions, you might actually find you run out of memory or something. Or you want to control that kind of thing. So you have those options. Once again, I haven't had a need to do this really, in most cases, except maybe on some CI cases where we have to change. But you have the flexibility should you ever need it. Then, currently, if you want to use diagram, it's very simple. You just have to say in the Asciidoctor extension, diagram version, give it a version. It will automatically figure out we need a version, it will get the correct artifact use and put it in a class path. Actually, coming up in 2.2, there's even a change, and I'll show which makes it even simpler. Okay, and then let's actually do it. That's generally all the kind of things that any Asciidoctor task can do. But we've now made it so that it's more generic and more specialist both sides. So the first thing we have is you no longer use the old Asciidoctor convert ID, you have to use org Asciidoctor JVM convert. If you upgrade from 1.5 to 2 and you just use org Asciidoctor convert, it will work. And it's going to give you a whole bunch of warnings that tell you everything you have to change. And if you change those and switch it, then you automatically get all of your functionality. So you have an upgrade path. Basically, if you apply that plugin, you will get an Asciidoctor task as before. And that Asciidoctor task has one or two extra features, besides everything else that I've shown you. You now configure the backend and etc. in an output options block. And basically, what will happen is, if you only specify one backend, it will write directly to your output directory. If you specify two, it has to basically split the output directory. The old behavior was to always add the backend name in that, and then people changed and things like that. And we always used to have a thing called separate output directory. So you still have that behavior, you can turn it on or off, but it's now in the output options block. And that's basically the extra that the Asciidoctor task itself adds. But we went much bigger than this. Traditionally, you had one task, try and do everything in. And then a lot of these backends behave differently. So for the core backends, we now have separate tasks. The first one has actually got a specific PDF plugin. So if you want to generate PDFs, just apply the PDF plugin, and you get this task called Asciidoctor PDF. But it now has special things that you can do. If you want to specify fonts to use in your PDF, you just tell it directly to the fonts. You don't have to go fiddle with setting an attribute on your task. The second reason for doing this is now Gradle can see the fonts directory has changed and rerun the task, which you couldn't really get with if you just put it as an attribute. And also then you have to say, well, oh, the directory has changed. I have to put in all the inputs files in there again, so that's gone. So it's got all of the intelligence built in. Also, you can use PDF themes now. So there's an extension called PDF themes, and it's got a couple of ways of doing it with local ones, or you can pick them up from GitHub or GitLab. And all you have to say is GitHub, you give the theme a name, like fancy, and standard kind of paths of attributes for GitHub, organization, etc., and then relative path. Relative path is actually a directory within the repo where the theme is actually located. And what this will do is it's not going to clone it, it's actually going to go to GitHub or GitLab and pull the zip archive for that specific tag or version and pull it down and unzip it. So you don't even see that, and once it's pulled it won't try it again until you clean the directory. Or you change any of those parameters. If you switch the branch or tag name, it will pull it again and expand it. So once you have the themes, you can just go, you can specify a local theme if you develop one locally, and then you just have to tell it where it's located. And then you just go back to your task and say, I want to use that theme, and it applies it. In a similar fashion, you can do EPUBs. Not many people really do that many EPUBs, but some do. And we did a couple of fancy things with the EPUB actually. But firstly, you have a task now called Asciidoctor EPUB if you apply the EPUB plugin. But you can see it's basically very modular. You only apply what you need. If you don't need any fitted, you don't get it. You can still actually use your standard Asciidoctor task and get like PDS EPUBs on it, but then you have to do all of the work yourself of putting on the attributes. You have to tell it explicitly in the extension to use a specific version, etc. If you use the plugin specifically for this kind of conversions, it just works. So with EPUB, you can tell it which formats you want to generate, normal EPUB or Kindle format. And the thing is, with the Kindle format, you need Kindle Gen installed generally. But now you don't have to do that either. Because all you have to do is you have to go to the Kindle. The moment you apply EPUB, it applies a Kindle Gen extension, and you just have to accept the terms of use of Kindle Gen. It will bootstrap it, it will pull it from wherever it is, it will put it in your Gradle cache, it will expand it, and it will put it on the path. So this brings it back to another kind of thing why Gradle is such an advanced tool. You can really, really automate your pipeline or set up a local development environment where people don't really have to install stuff anymore. Just make Gradle do everything for you. And this is one example of doing that. And then, the other familiar thing we have is, obviously, this is written in Real.js as well. We have a Real.js plugin now. And it takes away a lot of the manual manipulation once you get it to do. So, for instance, what you can do, so reveal.js gives you a bunch of fields. I just say I want to use the page feed. Where's my source directory, which file I want to include, and then instead of manipulating attributes again on the document, all of the standard reveal.js options are available in the block. And you can set many other ones. You just have to look at what the option is called reveal.js and you can set it here. And then once it was now great, if it changes, it knows it has to rerun. And that's the start that you can do, but you put more things going. The reveal.js plugin actually has to use a gem underneath. And traditionally, because of JRuby, you might have to have other things where you want to use gems as well. And traditionally, you had to apply the JRuby plugin for this. But because the JRuby plugin now develops at a much slower pace, and there's a couple of things that doesn't really quite work the way we want, we have our own gems plugin. And if you, for instance, use reveal.js, it automatically apply this plugin. But if you need other gems and you don't do that, you still have to apply it. And this is a simple example I want to use. I want to use the Asciidoctor BibTeX gem. And all I have to do is apply the gems plugin, give it the URL of talkbox to find the gems, and then give it the standard mailing coordinates. And then all I have to do at the bottom is to say required, which is the standard kind of thing we always have to do, is require a gem. And that will automatically end up so that it's acquired by Asciidoctor and you can use the things. It will work. It will be on the class path as well. There. Whoa. Okay, so we have a 2.2 release coming up. Actually, let's stop. Do you have questions before I go on to this path? Because I've just been talking. No, okay, right. 2.2 is coming up. There's a reason we want to do 2.2 now, because we are deprecating some of the DSL prior to the version 3 plugins coming out. So we don't want to have a big change. We give people a chance to change the way they change certain things in the DSL before upgrading. The first thing is that the word keyword extensions has been deprecated. We can use doc extensions instead. The reason for this is Gradle. And if you have an extension, a Gradle extension, and you have a get extensions method on it, it breaks the Kotlin DSL. So, we said, okay, we can wait for somebody to fix this, or we can just go with a better way, because the workaround is then to tell Gradle via annotation not to make your extension aware again. And I actually want that kind of functionality for future releases. So the easiest way is to rename it. So in future you actually have to use doc extensions. So you just have to go where you've done extensions, put doc extensions, and then it will work. And if you once this is out and you upgrade, it will actually warn you if you don't use the old extensions keyword, just say use doc extensions. And the way you set versions moves to the modules block. And that's the reason we had to do this as well, because it just gives a lot more flexibility. And especially one of the things I'll talk about, Gradle 3, mail is a real big requirement. And we'll just deprecate other ways of doing it. And once again, if you're going to set like Groovy DSL version or diagram version with a normal assignment, we'll warn you about it and tell you to put it in the modules block. But the great thing about a modules block is we can now do a lot more things. For instance, if you want to set a PDF version, we can do it one of two ways. You can say PDF and put a version in the closure block, or you can assign it. If you don't care about a version, you just want to use it, you just say PDF.use, diagram.use, and it will take the default version that's specified, which is generally the recommended version. So you don't even have to look things up, so it actually makes it a lot easier. And then Asciidoctor J2.1 is also coming up. And then once that's out, we can actually write a syntax highlighter in Groovy if you really want. But that's just the last part is really missing in that. Okay. Right. But this is the other thing I want to talk about. As I said, this is the first time we'll hear about this. There's just been rumors going on, but there's a branch for Asciidoctor Gradle 3. do, we don't know when it's going to be. It's going to definitely be based upon Asciidoctor J2, but one of the big things is going to have Asciidoctor JS integration. So you can actually run the JavaScript version or implementation of Asciidoctor instead of the JRuby version. The reason for this is there are certain extensions and converters and things like that that only works in the JavaScript version. Instead of ones that only work in the Ruby version. So now you can have the best of both worlds. If you find something like currently bespoke, which is probably one of the big use cases, doing bespoke JS with JRuby, you have this kind of size Gradle file to do it. So being able to do it with Asciidoctor JS would be a lot easier. And then other things we can add Deck2PDF integration into that. So let's talk about it. So Asciidoctor JS is going to look a lot like Asciidoctor J. Obviously, the things here I'm talking about here are crystal change. This is the concept, but there is a branch and it runs. Okay, you just have to apply something, probably JS or JS with Node.js convert, because the standard version will be based upon Node.js. And you will have an Asciidoctor JS extension instead of an Asciidoctor J extension. But the rest of the syntax looks the same. And then it is something really, really specific to like the JS version compared to the J version, then there will be different kind of things that you can set. The task will still look the same. So to a great extent, you should be able to switch from the one to the other one with a minimal of changes. But obviously if you've got extensions which runs in JRuby, it's not going to work on the JS version. So those kind of things they don't transfer, but basic tasks you can actually switch. And just to go back to that. So what we've basically done is we've run as the top of Node. You don't have to install Node, you don't have to install NPM. It takes care of everything underneath the hood. You can actually manipulate the version of Node you want to use for something if you really need to, or the version of NPM. It also gives us the flexibility of switching away from Node and using Yarn instead if you want to do that. But basically it will do that, and it will then actually run the build by firing off Node.js executable and run the conversion, and it just takes care of all the command line parameters and everything. The difference with this is it actually runs as a separate, just executable process, so we don't have to use workers or anything. So it also does suffer with any class path leakage problems. Okay, we're nearly done with this. Right. Deck2PDF. So we want to actually get integration. If you don't let everybody use Deck2PDF. Ever done this? So it allows you to take like the slides and export it, and not just the reveal.js, a bunch of other formats, to PDF, a set of JPEGs or PNGs. If you want to do it the old way, I have to split it over 2 slides. Basically, you have to create a configuration. You have to put the artifact on the class path of the configuration, and then you have to do all of that. You basically have to do a lot of manipulation and we'll run this Java exec task. So, yeah, it works. I mean, I've got it in this build so I can export the slides to PDF, but that's where we want to be. You just want to basically apply the plugin, and what it will do is it will simply, firstly, it's just going to add an extra extension if it's like, if this covers is like reveal, it will add an extension so you can configure additional things for the conversion for reveal. Let's go back to that again, and that's basically it. Then you could have a task which you can configure it, which is there, but basically you should be able to do something like that. You should just want to say, and I put 2 on there. So I have an Asciidoctor reveal.js task. All it does is just a convention. You just take the task name and put 2 PDF or 2 PNG on the command line. And he said, oh well, okay, I recognize the task, I'll go to that task, run it, generate all of the slides, take the slides, run the conversion, create a PDF of it, or a set of PNGs. And we plan to have a command line parameters. So if you want to switch a command line, like the width and the height on the fly, you can do it from the command. You can also configure it into the task. But that's the idea. Okay. comments?
I have one. When you say we, so which people are in the team? So Dan Allen is on Asciidoctor, and you are in the part of Asciidoctor J. And
Okay. Right, so the team. So, yeah, Dan is the big overall Asciidoctor project lead, the father of guidance, or whatever you want to call it. He mostly works on the Ruby core and on Antora. And yeah, he does, obviously just a core, he just does like a PDF converter, separate all the Ruby versions. Asciidoctor J itself, the main person behind that is Robert Panzer. And then on the Asciidoctor J side, there are a couple, but I think the main person is Guillaume Grossetti. Okay. Then on the Gradle side, currently it's mostly me, but it's also Andres. And generally it worked currently in a way because I had the time, so I wrote a lot of the code and say, Andres, this is ready. Here's the last PR to master, do this, and he would review it, and he would go and click all the buttons and release it. And that's generally the same branch we have on that. But I have actually done a lot of work on this. I mean, it's been, to go from Asciidoctor Gradle 1.5 to 2 was 10 months of work. Obviously it's not full time, but there was a lot of things going on, and I just spent a lot of time on that. So I'm like getting to a point where I want to do the last couple of things and step away for a while. I've been burning the candle on both ends, especially. And you still have a day job to do. Okay, so that's basically we. I mean, obviously, the ecosystem is big. There's lots of other projects with other people applying it, but it's the quickest people I could think about. Obviously, there's the Maven plugin, which is Abel Romano. Abel from Lisbon, Barcelona, which is from JDC and Conf as well, you know. So, wait, I can have a plug for that. If you don't go to GreatConf, unfortunately this year GreatConf and JDC and Conf are on the same dates due to a little comedy of errors. But yes, so I am involved in JDC and Conf as well. So if you want to do, if you can't make it to Copenhagen, maybe you want to do the 3 hours down to Barcelona by train. Okay, anyway, yeah, so there's that other person, and he just funnels through and makes the changes as he gets time. And there's a couple of other people as well. Right.
To me, one thing that I don't like is the GitHub closure. Why GitHub? I wrote the extension in GitLab.
There's a GitLab one.
But the word is GitHub.
No.
You have another GitLab?
If you want to use GitLab, you just say GitLab.
Yes. Ah, great.
It supports basically those two. Theoretically, we can support any Git, but because both of them support the standard kind of effectively way where you can just say organization, repository, and tag or branch, and it knows to retrieve archives it from it. That's why we do that. So GitLab is there. So I couldn't have missed it.
So we are friends, right?
Yeah. We could potentially do it for Bitbucket, but in Bitbucket, Atlassian doesn't want to support Asciidoctor properly on Bitbucket. So yeah. All right. Anything else?
Questions?
Yes, I have another question. Just came to my mind when talking about Bitbuckets. What if you have an organization which is putting all the documentation on Confluence? Is there some way of integrating that?
Yesterday I made a little progress in this. Well, I know the progress. I'm a beta tester. I was testing a plugin for Gradle, from Ralph, and it works.
Yes. Okay, so there is a solution.
So that generates HTML and puts that
you write a doc.
Yeah.
Run the Asciidoctor Gradle, and you have the HTML. And he has another Gradle plugin that can unlock the HTML to Confluence.
Yes.
And it works. First test, it works. The plugin is still very ugly. This is a work in progress.
Yes, I think it works via post request. Probably.
What?
It probably works via post request to do that.
The code is not published. I hacked it.
Oh, yes,
I
right.
was digging in the code pipe.
It might be possible because Atlassian's actually got APIs for Confluence. It might be actually possible to write something that works better than that, but that is currently the solution. PM Sharble, I think that's his surname, also did something in that he actually, but I think it only works with older versions of Confluence 5. So this, if you go on the Asciidoctor group in GitHub, I think there is also something for that. But yeah, but other thing is to use the doc. I forgot Ralph's tool's name. Jorge?
What? Sorry, I was looking for the Twitter that
Yeah, because I was
use.
thinking, what's the name of the tool? Doc Toolchain.
DocuOps.
No, that's a Doc Toolchain.
Yes, I'm looking the thread on Twitter.
Okay, how are we for time? I can tell you what the pains we had trying to write Gradle plugins for this. Do you really want to know? Or we can stop here, it's up to you.
As you prefer. I mean, we can take, I don't know, 5-10 minutes. Thing.
Okay, I'll give you a couple extra.
Y las imágenes solamente. Also the image, the plugin uploads also the image.
Oh,
Yeah.
oh, cool. Well, I think you've got a solution. Might not be perfect, might be better than nothing. Some of you will know, so actually, I've written 1.5 books on writing plugins for Gradle. One day the second one will be finished if I get time for it. The Gradle moves so fast that I don't get time to update it. Right, I've done a lot of plugins. But writing the Asciidoctor ones has been specifically complex because we wanted to really solve the user problem of giving you a very, very nice DSL in Groovy and try to be friendly as possible to the Kotlin DSL. And then we had to deal with bugs in Gradle. That's what really it comes down to. There's definitely things that's happened in Gradle where new features get released. There's a lot of noise made about it. But if you start really using it in anger, you still find issues. But at that point, to a great extent, they either don't have the time to fix it, or the original reason why they released the feature was to solve a problem for Gradle. So it doesn't really get enough attention. So we have to work around these things. We want to make sure that things are compatible. We use, in the Gradle, we use Schalk to test code coverage. We had to deal with issues of that. Obviously, as I mentioned earlier, we had to deal with things like serializing closures, which normal features don't even care about. But okay, so we had it. So Gradle bugs is definitely, the one thing is, everybody went, oh, you can use Gradle workers, it's better for your performance, etc. Because it will spawn things and will keep them active in the daemon, etc. Then you run them, and you find it leaks. They try to be too clever. It leaks things into the class path that should never be there. Things for internals from Gradle. If you run like a test in debug mode, and it uses a worker, suddenly the class path goes from this to this. So it leaks even more things, and then things break differently in debug mode than it breaks in non-debug.
Wow.
And that still remains one of the reasons why we definitely use JavaScript as the default mode. And this has been running around in circles because you can't find, because you think you're the wrong person doing something wrong. It should be easy, but it's not. Then 5.2.1 got released and things were working. And then suddenly we were testing, of course we actually test Kotlin DSL as well. We write things in Kotlin and Groovy as part of the compatibility. Couldn't figure out what it was. It was the problem in how they changed something and the fact that extensions are extension away. And we had to, luckily, got some feedback, we managed to put in a workaround. But that thing probably kept me busy for 2 or 3 weeks to try and figure out what's going on. And then the other thing is, if you write Gradle plugins, I know some of you might have, then you have to use something called testkit, which is to actually be able to run functional tests for Gradle. If you run it in debug mode, so you can step through your plugin, and you're testing a Kotlin script, it fails. So you can't actually debug things whilst running a Kotlin a bold Gradle KTS file. So you just have to hope it works. You have to write a whole script properly with bold Gradle, make sure it works, and then you have an extra one with bold Gradle KTS and just hope it still works. But you can't basically step through it. That is quite frustrating. Then the other thing there is we have to deal with Gradle API changes. Because when we started 2, we said, well, we're not going to support anything below Gradle 4, but we want to make sure it works from Gradle 4 to the latest release. There's a step change between Gradle 4.10.2 and Gradle 5, which is, it goes from Groovy 2.4 to Groovy 2.5. You have to deal with that.
Yeah.
Okay. I was quite impressed because Andres just said, how the hell did you manage this? Right, it works. Right, so the key is loss compatibility testing. So we use a plugin called Gradle Test, among things, which is you write real projects in Gradle, proper ones you would do normally, and you put like a bold Gradle file and a bold Gradle KTS file if you want to send directly, and then it runs it across all of the versions and it tests. And that's key because then you can start finding these. Now the things we run everything is basically statically compiled, but with selected dynamic Groovy you get around the issues of the changes between 2.4 and 2.5, so you can deal with that. The only thing that never worked was using collect. We had to actually go and use streams to actually get that to work because that just doesn't work. But okay, you know that, then you put something in, and we have a little API and just call set instead of calling collect, and that's fine. As I said, we use test kit as our first order testing. Then we use Gradle test for full compatibility testing. Because test kit we effectively only test with the current version, and it just effectively tests the functionality. If I want to write a script in this way, it should work, kind of thing. And currently, everything is tested from 4.0 to 5, except we skip 5.2 because 5.2 is a bit broken. And I think obviously for 2.2 we'll test 5.4 as well, but that's basically, that is the range of things we test. The full build, we actually had to do because Travis couldn't complete the build in an hour with all of the testing. So we now actually have conceptual things running on GitLab CI. We start everything in parallel. And you can just see, if I have to have a plug there, you can just see so much better that GitLab CI is than Travis. We still do our Windows tests on Advair. Advair is just very dependable, I have to say. You hardly have any issues with it. But once again, it doesn't have the kind of flexibility as with GitLab CI. And now, we basically just say we have all compatibility tests just run in parallel. So if you look at one of the screens, you see, we probably have about 6 or 7 parallel of tasks, pipelines running to get all the tests through, and it finishes now in about 14 minutes. So
do you run everything on the free GitLab CI stuff?
Yeah.
Because as it's an open source project, you have 3 minutes, right? Unlimited 3 minutes.
Yes. Well, I think you get throttled after a while.
But on time or on a minute?
No, on resources that are available. So it will take longer to kick in some of the jobs, that's all. You notice a lot more on Advair, where it sometimes takes like an hour, 2 hours before your job kicks off. If you ran a couple, the next one just gone to the back of the queue.
Mm-hmm.
I don't know if that's just that it gets used a lot or the fact that they physically throttle it. But yeah, it just works, they do a great job for us, so give them a plug anytime. Okay, yeah, code coverage, that was another thing came up. So we had to run Jacobi. We actually have about 83% code coverage. But in order to get all of the code coverage, you need to run test kit things with debug. Then you have an issue if you test a Kotlin one and it fails. We have to build things into the test to make sure that it turns off debug if it realizes you're going to test with Kotlin. The Gradle test plugin actually does that. I did a patch for that. It just says, oh, you're running Gradle KTS, always turn off debug mode. It just doesn't run it. So you get through that. So that just means that for the parts that we test with Kotlin DSL, we don't get code coverage. But generally, most of the code parts are followed anyway with the Groovy doesn't make a big difference. And then, yeah, kind of thing we had to do is you have to, if you really want to serialize closures, we had to put like that internal class on the class path to get it to work. And then we had to go figure this out as well. So we do a lot of manipulation. Firstly, we find out whether we've got any closures that's going to be on the class path. Then we go look for that class. So there is a special method with get class location which goes and figures out where it's on, which jar the swing is. It takes that jar off the resource and puts it in the class path. And basically that's what we had to do. And the other thing that's actually worked really well is because we had to do so much complex manipulation of the Asciidoctor class path. We didn't create a standard configuration, we created something in Gradle called a detached configuration, which you can do. So it's hidden from the user. So you can't actually directly go and manipulate it. Although you can, but I'll show you how. But what this can do is it can, for instance, say you've put on, especially with the older versions that actually have to do it. Are you running PDF? And right, we have to make sure you put the right version of Snake YAML on there. Manipulate that. Manipulate the version of JRuby if it's necessary. A lot easier if you just do the attached configuration underneath the hood. Which sometimes means you can actually have different configurations per task it runs, which is also a great thing. Otherwise you have to define different configurations manually. Now it's detached, it just gets created, so every task runs with its own configuration. And you can actually manipulate it on a class. Per task basis. And it also means that the configuration will only get validated if that task runs. Okay, so basically, the only other thing you can do is if you ever had to manipulate it, you can go into the extension and manipulate the resolution strategy. So for some reason you run something, you find a bug one day, because we have upgraded, and something goes wrong, you can actually fix it. But hopefully you never need to. So that's it, and then you can actually see that's the detached configuration. It just tells you everything that's on the class path. It's still there, except you can't get hold of it directly. I have to write the task to do that. And basically that's all we now put on the class path for a normal Asciidoctor task to run. Plus, if you use it for its extensions, it puts extra something on there. But if you run vanilla, that's all it puts on there. So it's really, really clean. Yeah, I think that's it. Yeah, that's.
Thank you very much.
Right.